Elon Musk has unveiled a new robot. Meta is facing a legal battle over the unauthorized use of copyrighted books. The week gone by was buzzing with a lot of exciting tech developments, and we bring you the most interesting ones in a tech wrap.
Elon Musk has just revealed a game-changing update in the world of robotics. Tesla's Optimus, a humanoid robot built to walk, work, and learn like a human, is now entering its third generation with major improvements. This new version promises more advanced capabilities and greater efficiency, all at a surprisingly affordable price. But the big question remains: can a robot like this truly transform our everyday lives and reshape the future of work as we know it? From concept to reality. Tesla's humanoid robot, Optimus, began as a futuristic dream, an ambitious project to create a robot capable of taking on dangerous, repetitive, or mundane tasks that humans would rather avoid. The vision was simple but profound: free human beings to focus on creativity, innovation, and complex problem-solving, while robots handle the physical labor that is monotonous, exhausting, or unsafe. However, bringing such a vision to life is anything but simple. The earliest public glimpses of Optimus were far from perfect. Tesla unveiled a prototype that looked awkward, clumsy, and unrefined. The robot struggled with basic locomotion, hesitating on stairs, unable to grasp objects with finesse, and lacking the fluidity of natural movement. Critics were quick to label it more of a novelty than a viable machine. Yet Tesla saw these early steps as just the beginning. What sets Tesla apart from other robotics ventures is their deep expertise in large-scale manufacturing and cutting-edge AI development, honed over years building electric vehicles that seamlessly combine hardware and software. Unlike startups that build robots as standalone projects, Tesla integrated Optimus development into their existing infrastructure. They reuse electric motors, battery technology, and autonomous software stacks originally crafted for Tesla cars. This synergy not only saves time and costs, but also accelerates innovation, allowing Tesla to push boundaries faster than anyone else in the field. The leap from Gen 1 and 2 to Gen 3 Optimus is more than incremental, it's transformational. Engineers rewired critical mechanical components, particularly around the ankle joints, to give the robot an advanced descent control system. This means the robot no longer stumbles or freezes at the top of a staircase. Instead, it moves gracefully and confidently, flowing down steps like a human dancer, calculating balance in real time every few milliseconds. This capability is essential for Optimus to become truly useful in real homes and workplaces, where stairs, uneven surfaces, and obstacles are common. Another major breakthrough is in tactile sensing. Early models had rudimentary hands that could hold a box but couldn't sense delicate textures or pressures. With Gen 3, Tesla outfitted Optimus with silicon fingertips packed with high-resolution sensors capable of detecting minute pressure changes and even temperature variations. This means Optimus can now perform delicate tasks like handling a ripe tomato without crushing it, or rinsing leafy greens gently under running water. The robot's sense of touch is key to building user trust. People won't feel comfortable having a robot in their kitchen unless it can handle food safely and precisely. Perhaps the most jaw-dropping element of Tesla's plan is their aggressive target price. While most humanoid robots on the market cost hundreds of thousands of dollars, Elon Musk hinted Optimus Gen 3 could be priced as low as $10,000, potentially even less. If true, this would make the robot accessible not only to factories and corporations, but also to everyday households. Imagine a future where millions of these robots quietly assist with chores, caregiving, and production tasks, revolutionizing the labor landscape. The economic and societal implications of such a breakthrough are staggering. Affordable humanoid robots could change how we work, age, and live. But Tesla's approach, blending automotive-scale manufacturing with AI-driven robotics, is what makes this vision plausible. They aren't building a one-off marvel, they're designing a mass-produced product that could become as ubiquitous as smartphones. If Tesla can truly make a humanoid robot as affordable and capable as a mid-tier smartphone, could Optimus become as common in homes as smartphones are today? The AI revolution inside Optimus. While the physical hardware improvements in Optimus Gen 3 are impressive, the true game changer lies in the robot's AI, the brain that controls its every move, decision, and interaction. Unlike traditional industrial robots programmed with rigid instructions, Tesla's Optimus uses a groundbreaking learning framework designed to mimic human cognitive development. Tesla calls this approach training, not coding. Instead of manually programming every single motion or task, the robot learns through observation, imitation, and repetition, much like a child learning to navigate the world. It watches videos or demonstrations of tasks being performed and then attempts to replicate them, making adjustments based on success or failure. This approach allows Optimus to adapt to new environments and unpredictable situations without requiring explicit instructions for every scenario. During the initial phases of learning, teleoperation is key. Skilled human operators remotely control the robot's limbs, guiding it through the exact movements needed to complete tasks. The robot records detailed data on these actions, how much pressure to apply, the angle of each joint, timing sequences, and then practices these movements autonomously. Through countless cycles of trial and error, Optimus gradually refines its skills, improving both speed and precision. One of the most striking demonstrations of this AI in action happened during Tesla's public demos when Optimus accidentally dropped a battery cell. Instead of waiting for human intervention, the robot immediately corrected the mistake by reorganizing the items on the tray. This moment was not scripted. It showcased real-world adaptability and autonomous problem-solving, two qualities essential for a practical service robot. Despite these advancements, challenges remain. Natural language understanding is imperfect, meaning Optimus might misunderstand voice commands or fail to grasp nuanced human speech. Complex object manipulation, such as dealing with slippery or oddly shaped items, requires further refinement. Navigating diverse environments, from cluttered homes to busy factory floors, also tests the robot's perception and balance algorithms. Tesla acknowledges these hurdles and is committed to addressing them with continuous software updates and real-time self-correction capabilities. This iterative process mirrors how humans improve over time, embracing imperfection as a step toward mastery. The implications of this AI-driven approach extend beyond mere automation. By enabling robots to learn and adapt like humans, Tesla is pushing the boundaries of robotics from fixed-function machines to versatile companions capable of evolving alongside their users. This shift could redefine industries from manufacturing to eldercare and fundamentally change our relationship with machines. As Optimus's AI grows smarter and more self-reliant, could it soon surpass human dexterity and become indispensable in countless everyday tasks? Real-world tasks and deployments. Tesla has ambitious plans to deploy Optimus in environments where its unique skill set can make an immediate impact. One prime application is inside Tesla's own factories, especially the upcoming Cybercab production line at Gigafactory, Texas. Here, Optimus will supplement human workers by handling repetitive assembly tasks, quality inspections, and logistics. Replacing 2 to 3 humans on certain tasks, Optimus promises improved consistency, speed, and precision, helping Tesla ramp up production to meet growing demand. Elon Musk envisions production lines where cars come off the assembly line in under 5 seconds, an almost unimaginable feat enabled by humanoid robotics. Beyond factories, Tesla sees Optimus playing roles in disaster response zones, hospitals, and even domestic settings. Household chores like cleaning, cooking, and laundry are within reach. The robot's ability to learn new tasks means it could adapt to specialized duties such as elder care, offering round-the-clock vigilance and assistance to vulnerable individuals. Of course, for this vision to become reality, Tesla must overcome challenges including mobility across uneven terrain, reliable voice recognition, and seamless interaction with humans. Progress is steady, with pilot programs slated for 2026 and commercial units expected by 2027. With Optimus preparing to enter factories and homes soon, are we on the cusp of a robotics revolution that reshapes work and daily life? Economic and social impacts. The widespread introduction of Tesla Bot Gen 3 could trigger profound shifts in economies worldwide. Automation of repetitive, dangerous, or physically demanding jobs promises productivity boosts and safer workplaces. However, this also raises concerns about workforce displacement and societal adaptation. Tesla acknowledges the potential disruption and has proposed retraining programs for workers whose jobs may be replaced. The transition will require investments in education and skills development to prepare people for new roles overseeing and collaborating with robots. Economists predict that while some jobs will vanish, new professions in robot maintenance, programming, and AI oversight will emerge. The challenge lies in managing this transition equitably and preventing unemployment spikes. Moreover, consumer markets may be transformed as labor costs drop and goods and services become cheaper. Household robots like Optimus could free up human time, changing lifestyle dynamics and potentially fostering new industries. Yet, fears remain about the pace of change. Skeptics warn that unregulated automation could exacerbate inequality and erode middle-class employment. Governments and corporations will need to develop thoughtful policies balancing innovation with social welfare. As Tesla Bot Gen 3 promises to transform the economy, will humanity harness this change for good, or will we stumble amid rapid disruption? Technical breakthroughs in Tesla Bot Gen 3. Tesla Bot Gen 3 is not just a robotic upgrade, it represents a fundamental shift in humanoid robot design. The engineering team has overhauled critical systems, combining advances in electric motor efficiency, battery technology, and AI-driven control to create a machine both nimble and resilient. One of the standout technical achievements is the integration of Tesla's proprietary 4680 battery cells. These batteries, originally developed for Tesla's electric vehicles, are lighter, more energy-dense, and more efficient than previous generations. By embedding these cells directly into the torso of the robot, Tesla has dramatically reduced the weight and bulk that characterized earlier iterations. This design tweak not only improves balance but also extends operational time, allowing Optimus to work autonomously for up to 10 hours on a single charge. Mobility has long been a challenge for humanoid robots. Gen 2 robots often struggled with navigating stairs or uneven terrain, limiting their usefulness. Gen 3 addresses these issues through redesigned ankle geometry and a dedicated descent control system. This system streams inertial measurement data every 4 milliseconds to a predictive balance model that allows the robot to flow downstairs gracefully, avoiding the jerky, hesitant movements of before. Sensory feedback is another area where Tesla has pushed the envelope. Optimus's hands now feature silicon fingertips capable of detecting minute pressure changes, temperature shifts, and even subtle vibrations. This tactile acuity allows the robot to interact with delicate objects. Imagine handling a raw egg without cracking it or rinsing vegetables without bruising them. The soft collision sensors embedded in the fingertips also enhance safety, reducing the risk of accidental damage or injury during operation. On the software side, Tesla's AI team leverages deep learning techniques trained on massive datasets derived from both Tesla vehicles and human teleoperation inputs. The robot learns not through static programming, but through repeated observation and trial, mimicking human behaviors with increasing precision. Early tests have demonstrated the ability to fold clothes, serve drinks, and perform kitchen tasks autonomously, actions once thought too complex for machines. Security is another critical facet. Tesla has implemented a multi-layered trusted platform module backed by firmware validation that rejects unsigned software updates, preventing unauthorized code execution. In the event of tampering or theft, the robot's Sentry mode activates an 80-decibel alarm, live streams GPS location, and locks down joints, transforming Optimus into a smart, autonomous guardian as well. While the robot is built for robustness, it also has an IP54 rating, meaning it can operate safely in light rain, through steam, and in dusty environments. This resilience is crucial for deployment not just in homes, but in industrial and medical environments where conditions are unpredictable. With such groundbreaking tech packed inside a humanoid form, could Tesla Bot Gen 3 become the first truly versatile robot to enter everyday life? Safety and ethics. Introducing humanoid robots into homes and workplaces inevitably raises questions beyond technology. What about safety, privacy, and ethical implications? Tesla Bot Gen 3 has been designed with these concerns front and center, but the conversation around robotics ethics is just beginning. The safety features embedded in Optimus reflect an understanding that humans must trust robots to coexist safely. From collision detection and emergency fall response to the robot's ability to summon help if it detects a human fall, Tesla aims to mitigate risks associated with physical interactions. Elon Musk has emphasized that Tesla Bot is built with friendly intentions, designed to assist rather than replace humans. The robot's capabilities to sense environmental hazards, identify obstacles, and make autonomous decisions are tested rigorously to prevent accidents. Privacy is another frontier. Robots equipped with cameras and microphones must balance functionality with user confidentiality. Tesla's approach includes local data processing where possible, minimizing cloud reliance and offering users control over data sharing. The robot's live video streams activate only under specific security conditions, such as theft attempts, to protect user privacy. Ethical use policies remain a gray area. What happens if Optimus is used in ways that raise societal concerns? Mass surveillance, unauthorized labor replacement, or worse? Tesla is working with regulators and industry groups to develop standards that ensure responsible deployment. The company's commitment to software updates means that as new challenges arise, solutions can be rolled out quickly. The economic impact also ties into ethics. Tesla has pledged free retraining for workers displaced by automation, a nod towards social responsibility. Yet, questions remain about the pace of change and whether society can adapt quickly enough without creating inequality or unemployment spikes. Philosophically, the advent of humanoid robots provokes deeper questions. What is the future of human labor? How will relationships evolve in a world where machines handle caregiving, companionship, and even creativity? Optimus may be a tool, but its presence challenges our notions of purpose, autonomy, and coexistence. As Tesla Bot Gen 3 prepares to enter our lives, will society embrace the robot revolution, or will ethical challenges slow its advance? Tesla Bot Gen 3 in industry. Tesla Bot Gen 3 is not just designed for home assistance, it's gearing up to revolutionize industries that rely heavily on manual labor. The vision is bold. Robots that can work alongside humans, taking on repetitive, dangerous, or precision tasks, thus boosting productivity and safety across manufacturing, logistics, and beyond. One of the most anticipated deployments is within Tesla's own factories, especially the Gigafactory in Texas, where the Cybertruck production line is ramping up. Here, Optimus is expected to replace 2 to 3 human workers per task in specific assembly and inspection roles. Unlike previous automation attempts focused on specialized robots, Optimus offers versatility. It can fold clothes, handle delicate components, and even perform quality control inspections without specialized tooling. The idea of a robotic legion of tens of thousands of units circulating the factory floor is no longer sci-fi. Elon Musk's statement about producing 5,000 Optimus robots in 2025 and scaling up to 50,000 the following year is staggering. Imagine a workforce where robots handle physically demanding tasks, freeing human workers to focus on supervision, innovation, and higher-level decision-making. Beyond Tesla, the potential applications are vast. Warehouses could see Optimus stacking crates, threading wiring harnesses, or performing inventory checks. Hospitals might deploy humanoid robots to assist nurses with routine tasks or support patient mobility. Disaster zones, where conditions are hazardous for humans, could benefit from Optimus's ability to operate autonomously and withstand challenging environments. However, the shift is not without challenges. Retraining displaced workers, managing the economic transition, and ensuring smooth human-robot collaboration require careful planning. Tesla's commitment to free retraining programs signals awareness of these concerns, but the societal implications remain complex. From a technical standpoint, integrating Optimus into existing industrial workflows involves adapting AI to varied environments, handling unpredictable variables, and ensuring safety standards that meet or exceed human capabilities. Tesla's experience with vehicle AI gives it a unique edge, enabling Optimus to leverage lessons learned from autonomous driving to navigate complex factory layouts and dynamic human interactions. In the long run, Tesla Bot Gen 3 could redefine the very nature of labor, transforming industries that have been stagnant for decades. The transition from manual to automated labor will reshape economic models, potentially boosting efficiency, but also demanding thoughtful policies to manage workforce changes. If Optimus can transform factories, what happens when it ventures beyond assembly lines to reshape entire industries and even daily life? Public reception and market potential. The idea of a humanoid robot walking into homes and workplaces brings excitement and skepticism. Public reception will play a crucial role in determining whether Tesla Bot Gen 3 becomes a household name or remains a niche technology. Pricing is a major factor. Elon Musk's projection of Optimus costing as low as $10,000, potentially as much as $20,000 by 2026, places it in an unprecedented price bracket for humanoid robots. This cost aims to make the technology accessible beyond corporations and research labs, reaching middle-class consumers and small businesses. The proposed monthly lease of approximately $499, including maintenance and battery swaps every 4 years, suggests Tesla is betting on service-based ownership models similar to electric vehicles. This approach could lower barriers to entry and create steady revenue streams. But the true test will be trust. Early adopters will scrutinize Optimus's reliability, safety, and ease of use. The ability to handle delicate household chores without causing accidents, respond accurately to natural language commands, and adapt to different home layouts will be critical for consumer confidence. Tesla's emphasis on AI-driven learning is a double-edged sword. While it promises a robot that improves over time, early users may face bugs, miscommunications, and unexpected behaviors. Transparency about limitations and robust customer support will be essential. Privacy concerns are heightened with humanoid robots equipped with cameras and microphones. Tesla's data policies and local processing efforts aim to address these fears, but the broader societal conversation about robot surveillance and data security will continue. On the corporate side, the promise of Optimus automating manual labor while coexisting with human workers offers compelling productivity gains. Companies focused on logistics, manufacturing, and elder care could see significant benefits. Market competition is heating up. Other tech giants and startups are developing humanoid robots, but Tesla's vertical integration, from AI development to battery manufacturing and structural design, provides a distinct advantage. The company's ability to rapidly scale production could make Optimus the most widely available humanoid robot within the next decade. Consumer culture and media portrayal will also influence market success. Tesla's track record of bold promises and occasional delays may cause some to temper expectations. However, successful demos showing real-world tasks and autonomous decision-making could shift perceptions dramatically. Social acceptance may grow gradually as robots move from industrial settings into everyday environments. The potential for Optimus to serve as a caregiver, helper, or companion raises questions about human-robot relationships that extend beyond utility into emotional and social realms. If Optimus wins hearts and homes, Will it redefine what it means to live and work in the 21st century? The ethical frontier. As Tesla Bot Gen 3 edges closer to mass production, a pressing question arises. What ethical challenges will this new generation of robots bring? The line between machine and human helper blurs, and with it come concerns about autonomy, responsibility, and social impact. One core issue is accountability. When Optimus performs tasks independently, who is responsible if something goes wrong? Imagine a robot caregiver that fails to detect a fall, or a factory bot that damages equipment or injures a human coworker. Tesla's layered hardware security and fail-safe protocols aim to minimize such risks, but no system is infallible. Legal frameworks are currently ill-equipped to address these emerging scenarios, leaving gaps in liability and compensation. Privacy is another significant ethical concern. Equipped with cameras, microphones, and AI capable of continuous learning, Optimus collects vast amounts of data about its environment and users. Although Tesla asserts strong privacy protections and data encryption, skeptics worry about potential misuse, whether by hackers, corporations, or even governments. The specter of pervasive surveillance, even in one's own home, sparks debate about consent and control. Moreover, the social implications of humanoid robots are profound. As robots take on caregiving roles, companionship, or even child supervision, the nature of human relationships might shift. Will reliance on machines lead to isolation, or can robots augment human connection? Could this technology exacerbate inequalities if access is limited to wealthy individuals or nations? The ethical design of AI also comes under scrutiny. Tesla's approach of teaching robots through observation and trial and error mirrors human learning, but raises questions about unintended biases or harmful behaviors learned from flawed data or environments. Ensuring robots act in socially acceptable and safe ways is an ongoing challenge for AI developers. Furthermore, the economic disruption caused by widespread automation introduces moral dilemmas around job displacement. Tesla's promise of retraining displaced workers is a step forward, yet large-scale societal shifts will require policy innovation, education reform, and new social safety nets. Philosophers and ethicists debate the long-term consequences of humanoid robots gaining increasing autonomy. Questions about rights, personhood, and machine consciousness, once relegated to science fiction, are becoming urgent topics as robots like Optimus evolve. If the ethical puzzles around Tesla Bot can be solved, what revolutionary new roles might these robots play in our society's future? The road ahead. Looking beyond the immediate applications and challenges, Tesla Bot Gen 3 represents a profound leap in humanity's relationship with technology. It is not just a machine, it's a symbol of a future where the boundaries between human effort and robotic assistance dissolve, potentially redefining daily life, work, and even identity. One vision sees Optimus as a gateway to increased human creativity and innovation. By automating mundane and hazardous tasks, humans could dedicate more time to complex problem-solving, art, science, and interpersonal connection. In this scenario, robots become collaborators, amplifying human potential. Conversely, the robot revolution could intensify societal divides if access is uneven, or if automation concentrates wealth and power in the hands of a few. The geopolitical implications are immense, as countries that master humanoid robotics might gain strategic advantages in manufacturing, defense, and economic resilience. There is also the philosophical question of purpose. As robots handle more physical tasks, how will humans find meaning and value in work? Will leisure, education, and social engagement fill the gaps, or will new forms of fulfillment emerge? Tesla Bot's ability to learn and adapt hints at future machines capable of empathy, companionship, and perhaps even creativity, complicating traditional notions of personhood. In parallel, the environmental impact could be significant. Optimus leverages Tesla's advances in electric motors and batteries, promising a lower carbon footprint than conventional industrial machinery. Widespread adoption of electric robots could reduce reliance on fossil fuels and contribute to sustainability goals. The timeline Elon Musk outlined, commercial sales beginning in late 2025, sets a tight schedule for these possibilities to unfold. If Tesla succeeds, it could usher in a new era of robotic ubiquity within a decade, reshaping economies and societies worldwide. Still, uncertainty remains. Development hurdles, unforeseen technical challenges, regulatory barriers, and social resistance could slow progress. Yet the momentum behind Tesla's vision and the convergence of robotics and manufacturing expertise make it clear that humanoid robots like Optimus are poised to become a defining technology of the 21st century. If Tesla Bot Gen 3 is just the beginning, what's next in humanity's evolving dance with intelligent machines? Industry revolution. Tesla Bot Gen 3 is not just a futuristic gadget for the home. It's gearing up to revolutionize manufacturing and logistics at a scale never seen before. Elon Musk's vision for Optimus is deeply intertwined with Tesla's own production lines, especially the ambitious Cybercab factory at Giga, Texas. Here, humanoid robots will perform tasks ranging from assembly to quality control, accelerating production speed and consistency beyond human capability. One of the most impressive aspects of Gen 3 is its versatility. Unlike specialized industrial robots fixed to one task, Optimus is designed to adapt on the fly. It can fold clothes one moment and the next, thread complex wiring harnesses in automobiles. This flexibility makes it a game-changer for factories aiming to reduce downtime and retrain human workers for supervisory roles rather than repetitive labor. The impact on logistics is equally profound. Warehouses overloaded with orders could deploy fleets of Optimus bots for picking, packing, and shipping, optimizing throughput while minimizing errors. In fact, Tesla predicts that just 5,000 Optimus bots, the equivalent of a Roman legion, could handle massive workloads that currently require tens of thousands of human workers. However, this revolution comes with challenges. Integrating robots into human-dominated environments raises questions about workplace safety, job displacement, and retraining programs. Tesla's promise of free retraining and workforce transition support is notable, but implementing these on a large scale is complex and requires cooperation from governments, unions, and corporations. The ripple effects could extend beyond Tesla. Competitors like NIO in China have already started deploying humanoid robots on assembly lines, but Tesla's fully integrated system, combining AI and vertical manufacturing control, offers a distinct edge. The company's ability to produce robots at scale and relatively low cost may force an industry-wide shift toward automation, pushing other manufacturers to accelerate their own robotic initiatives or risk obsolescence. Could this spark a new industrial revolution powered by intelligent humanoids? The potential for increased productivity, reduced injury rates, and more sustainable manufacturing is undeniable. Yet the social and economic landscape will need to adapt quickly to absorb the workforce changes that follow. If Tesla's factory floors are just the start, how will Optimus reshape service industries and everyday life? The public reaction. As Tesla Bot Gen 3 prepares to enter homes and workplaces, public opinion is a mosaic of excitement, skepticism, and genuine concern. The idea of having a humanoid robot that folds laundry, waters plants, or even watches over elderly relatives ignites imaginations but also fears. On one hand, enthusiasts celebrate the potential for increased independence and improved quality of life. For aging populations or those with disabilities, Optimus offers a promise of reliable, patient assistance that human caregivers cannot always provide. Families could delegate routine chores or safety monitoring, freeing time for meaningful interactions. But the darker side of public perception cannot be ignored. Images of robots replacing human workers provoke anxiety about unemployment and economic inequality. Science fiction has long fueled fears of AI uprising or loss of control, nightmares that resonate with a society grappling with rapid technological change. Tesla's transparency about Optimus's capabilities and limitations is critical here. The company's candid demos, showing real mistakes and ongoing learning, help humanize the technology and temper unrealistic expectations. Still, trust remains a major hurdle, especially when robots handle sensitive tasks like caregiving or security. Media narratives also shape the cultural conversation. Sensational headlines about robot overlords clash with hopeful stories of companionship and innovation. Social media amplifies both optimism and fear, often with little nuance. Education and public engagement will be key to easing the transition. As Tesla Bot becomes more common, society will need to develop new norms, regulations, and ethical guidelines to govern human-robot interactions. Schools and workplaces may need to teach new skills related to robotics and AI collaboration. So, is Tesla Bot Gen 3 the future of home and factory robotics, or just hype? Let us know what you think in the comments below. Don't forget to watch our next video for more on Tesla's latest innovations.